Hello and welcome everyone. So now we're again going back to the machine learning track, and as you know that we are learning a lot of stuff parallelly, so we'll go back to machine learning. So in the machine learning we had our introductory lecture in which I just introduced what machine learning is and what are the different types of tasks, and in that I just would like to revise a very important concept that we named as machine learning pipeline. So a typical machine learning pipeline, how does it look like? So in that the first step was data collection. Okay, I'll write a little bit smaller because I know this pipeline is going to get bigger. So we had this, the first was data collection. Okay, and then the second step was data pre-processing. Data pre-processing. And then the third step was feature engineering. Okay, after that we had how do we split data, but I won't write that, and that will be considered as part of feature engineering. Then we had selecting a model. Okay, the model, selecting and training the model, selection and training, because selection of the model is just one decision that you have to make. The main important step is that you have to train the model. So after we have this, let me just write it with red also, selection and training. Okay, after once you train the model, then you have to do model evaluation. Okay, so what you basically do is, so you do model evaluation. Let me write it over here, model eval. So what is this model eval? Basically you take as you know, you split the data over here in three. You have train, you have test, and the validation. So you keep the test data separate so that you will test it later. But here when you evaluate the model, you have trained a model, you want to evaluate, you use the validation set usually, and after that once you get it, you do parameter tuning. So in the same step, once you evaluate the model and you tune the hyperparameters, I'll say model eval and hyperparameter tuning and hyperparameter tuning. Okay, I am just combining certain steps, and once you have that, after that at the end, once you are run that, I have collected data, pre-processed, did the feature engineering, selected the right model and trained the model, and then I set the hyperparameters rightly, and then at the end what you will do is you will do the model testing. Okay, you will perform model testing because you want to see how generalized the model now is. If I have trained it on some test data, some trained data, and then I want to see actually if the data was not shown to it, how better it would be. So once you are convinced about the test of the data, and after that you take the model and you deploy it somewhere, maybe in the web applications or maybe wherever you want to use it. So you deploy it, you do the deployment of the model, and after that last step that's very important is you keep on monitoring the process and you maintain it, you monitor and maintain. Okay, now you can see. So these steps sort of happen, some happen parallelly, some happen sequentially. So the first step is data collection, and after that you do this, you have data pre-processing, and after that you do feature engineering, after that model selection, after that you see model and you evaluate the model and do parameter tuning, and then you do the model testing. Once you are convinced the model is good, then you deploy the model, and then you monitor and maintain the model, and then it can be an iterative process. Again, you can collect more data, again do some processing on the data, keep on using the same model and train it again. So this is a generic pipeline. Okay, this thing over here is a generic pipeline which we discussed probably in detail in the previous session. So here if you see, the most important thing that you can see, at least these three steps are they somehow directly involve data, because as you know that deep learning or machine learning, it is mostly dependent on data. So these three important steps are on the data, and they are the most. When you will do the real time some project, you will see that most of your time, sometimes 60 to 70% of time, your time goes here in data collection, then data pre-processing, and then feature engineering. Okay, now in these set of sessions probably we'll have a couple of sessions on this, so we'll see what to do over here. And because then this is our main machine learning and deep learning, maybe these steps will contain that, and this is our ML ops. So this thing contains ML operations. Okay, and these three steps, let me just change the color so that this over here, if you see, this is data part, these three things are data, and if you see this, this, and this. So this thing will contain our machine learning and deep learning, whatever we'll read about machine learning and deep learning. Okay, so if you again see this, so this is concerned with the data. Okay, and these three things are the models and the things that we'll see in machine learning and deep learning. And this is once we know how to do this, and then we'll have to deploy the model, continuously monitor, and this will be dealt in MLOps. Okay, so now the most important step that we'll take in next couple of sessions is this. Okay, this part that deals with data, because I have told you one rule: garbage in, garbage out. Doesn't matter how much better your model is, how much complex your model is, if your data is garbage, model is going to learn garbage. I generally give an example in offline sessions that it is like having a kid, and if that kid is given very bad environment when he grows up, and there are very high chances that irrespective of how brilliant the kid was, irrespective of how much intellectually well he was, the kid has high probability of getting ruined, of getting badly affected, okay, because of the environment. So similar, if you see this, whole of the things that a model learns is based on data. Okay, so whatever parameters you tune and whatever parameters you learn, it is learned from the data. So it is very important, I cannot emphasize that enough, it's very important to have first the good quality of data and a good amount of data. In deep learning, amount of data also matters. There are something called as scaling laws. The more data and more resources you have, the better the model performs. So that's what you have been seeing in these large language models. Initially they come up with GPT-2, GPT-3, GPT-3.5, GPT-4, something like that. But what they are doing is they are increasing data and increasing compute power. So I'll just write it. These are called as scaling laws. I write it as corner, scaling laws. Okay, initially many people are not supporting this scaling law. They're saying that we should come up with new techniques. It doesn't matter how much data we take. Some people are very supporters of this, and they were saying that if you increase data and if you increase compute resource, then you will get better models. So now we'll have to look into this data part. Okay, so that's the most important thing that we'll discuss in the next couple of sessions about this data. Remember this: garbage in and garbage out, so that you have to emphasize enough on this data. Now what will you do in the data? So we'll do two things, at least two things in this data. We'll perform what is called as EDA. Okay, this is called as exploratory data analysis. Exploratory data analysis. Okay, and then we'll also, this is one thing that we'll learn. We'll also learn data pre-processing and preparation. Processing and preparation. Okay, maybe most of these things will go over here. So first we have to explore the data. Okay, we'll start with this EDA, and then we'll intermix them. It's not that we'll just focus on EDA, but because EDA and this data pre-processing, it is somehow done in intertwined fashion. You do something and then you got some insight and you apply it on the data. You keep on preparing the data. The main goal is to prepare the data and understand it. Okay, and now we'll see what this EDA is, and we'll take after that in the middle we'll somehow chip in this data preparation and pre-processing, and we'll sort of cover these are the three important steps that we have to cover: data collection, data preparation, and then feature engineering. Okay, so now what we'll see what this EDA means. Not difficult, pretty easy, but the only thing is you should know it, because sometimes it becomes art more than a science. It becomes art. The more you do it, the better you become at it. Okay, so what is science? Just taking a digression. So science basically is if you can reproduce it again and again. Okay, if you do something once and if you again have the same conditions and you can reproduce it, it becomes science. What is art? Art sometimes is you can't explain it. You are saying that the more you see it and people become better at it. Okay, so sometimes this feature in this ADA, explore data analysis, because you explore and analyze the data, so it becomes an art sometimes, because the more the people do it, when they do it more, they come up with nuanced approach and they come up with something which maybe a person who has just learned EDA doesn't come with it. So the point from here is you must take is that you should do a lot of this EDA whenever you are, and many people are doing some project with me and they know that we are in the phase of the data collection. Okay, now I'll give you a brief definition of what EDA is. Okay, what is this EDA? You know, I don't like to write definitions, but I will just speak it out verbally. So EDA basically it's a process, simple process. It's a very systematic process, but okay. So it includes you inspect the data in this. Okay, you clean the data in this. You transform the data. Okay, so the things that you do. Okay, the things that you do is you clean the things. You clean. Okay, you inspect the data. You clean the data. You transform the data somehow. All these things and a lot of more things you will do is and then what is the thing that you want to achieve? Okay, what are the goals that you want to achieve? The things that you want to achieve after performing EDA. The first goal is you want to uncover insights. Okay, you want to uncover insights because you want to give some really good insights that was not directly seen from the data. Okay, and then what you do is you want to summarize the things, that you want to summarize the data. This is what my data is about. And then you want to create visualizations for storytelling, or if you have to communicate, I'll say communication or communication. Okay, and the best part is what I'll write is understanding. You'll understand the data. Now, why am I saying this is the best part? Because if you see computer science, some people claim that computer science is not real science. Okay, it is just a tool which is getting applied somewhere. Okay, so if you see in that, we are not domain experts. By no means can a person be domain expert in every field. Let's suppose I am working in med AI, but I don't know medical. I have very less training in medical. People who have studied it for decades and maybe thousands of hours, so they know way better than me what I know about medical. But I know maybe a little bit more about machine learning and this computer science than them. Now the point is, if we have to merge it somehow, so if we have to merge this knowledge, because you now see that computer science is a tool that is getting used anywhere in the real, not just many places, it is getting almost used everywhere. So now in order to understand the data, you should have a domain expert where you can communicate. So this EDA helps you there, okay, because you have certain features in that, and then you ask right questions to domain experts and ask them, okay, what should be done in this, what should be, and what does this feature mean, okay, is it important, is it not important? You have a discussion with them so as to understand this data, and that is the part of EDA. Okay, and most of the people that are here, probably you'll be working in different domains and you'll be using machine learning techniques. Some people will work in healthcare, life sciences, physics, chemistry, maybe some other things, and there are a lot of subjects. So wherever you work, it is not necessary that you know everything about the subject. The necessary thing is that you should be willing to learn, and you should be willing to ask right questions, and then you should be able to understand the domain, understand that bare minimum of the domain which is required basically. Okay, otherwise if you see, to solve a problem we need to have multiple expertise, but it's not always required. If you have an expertise, you can develop the other one. Okay, that's why in this area we'll understand this data. Okay, it's not just a technical step. Okay, but it is also a creative process. As I said, it's a creative process where you have to get creative, you have to ask right questions, you have to find hidden patterns. Okay, as I said, I'll uncover the insights, uncover the hidden patterns, see the trend, say different, and ask questions. Be like what I can say, Sherlock Holmes, or be like some detective. You have the data and you basically take the data and ask it right questions. Okay, so there are memes made on this subject, like when you give a data scientist data, so he squeezes everything out of the data. Basically he asks right questions to the data. Okay, and then the data basically expresses itself in front of the people who ask the right question, and it's very important to do because you have to prepare data for the model. It's sometimes really important if you do this step right, and then you can make a simple model. Okay, rather than having a complex model, you can make a simple model, and then simple model will be way better than the model, a complex model. And sometimes it happens, people use complex models and they don't give good results, but when they look at the data and there was some problem with the data. Okay, has happened with me innumerable a number of times. I can't remember how many times have I done this. Okay, there is a problem in the data. Okay, and why is this important? Now the first thing is, so it gives you the understanding of the landscape. As I said, these are the goals, so I'll just write the importance. Can't emphasize this enough. That's why I'm taking a little bit more time to explain you this. I don't know why is it not giving me more pages. Give me a second. Okay, so why is it important? I'll just write a few lines about why is it important. Why is it important? I'm speaking about EDA. Why is EDA important? Okay, the first thing that I'll say is you understand the data landscape. Understand the data landscape. By that what I mean, I just said that EDA provides you the comprehensive overview of the data set, like includes structure, identifies if the data type is numerical, if it is categorical, what's the shape, size, and everything about the data. And then it says you whether there are missing elements, what are the things that you can, maybe I'll write few of them. The first that you see is type of data. What type of data do you have, and are there some missing elements? Okay, how many data points are there? Okay, and what types of features are there, and what features are basically there, and other things. And then it says if you have these missing values, so how to deal with these missing values, and what type of distribution does each feature follow. Okay, all these questions you'll ask it. Okay, and when you ask these right questions, then what you can do is you can basically unveil the patterns. Okay, then you will unveil the patterns. There will be some hidden patterns which are not directly seen by the naked eye, but once you ask these right questions, so what kind of patterns you can see? You can see trends in the data. So there is a particular trend it is following. If you see, there are correlations. Okay, there are correlations in the data. This variable somehow impacts this feature impacts this. There are these correlations, and then you can find seasonality. You can find a lot of stuff in this, a lot of patterns in the data. Okay, and one more thing that you will do is you will detect anomalies. You can detect can detect anomalies and outliers. Sometimes you feel that this point is not making sense. When you do this exploratory analysis, what you feel is, okay, this point does not look to follow the norm, so it is somewhat outlier. You can remove that, and you can see, you can ask questions what to do about these outliers. Okay, and then after you have this, the more important step is, once you have this, you can do feature engineering. So feature engineering and feature selection and selection. That's the third step. So if you see the pipeline that we have discussed, so in this, if you see this feature engineering, so this only can be done once you understand the data. That's why you are asking the right questions. So once you have this, once you perform this EDA, so you will do this. So you will feature engineer, basically you will engineer the features, what features to take and what not to take, and then you will select the features. Okay, so these things can be done. And then the most important thing which people do, they'll formulate hypothesis. They'll formulate hypothesis. So what is this formulation of hypothesis? Then when they see the data, they say something about data. They say, oh, I feel this is that, and then you have to do formulation. You have to do hypothesis validation. Okay, is this actually the right thing? Let's suppose if you claim something about data because you saw something in data and you formulate the hypothesis, and this kind of mathematical formulation. It's not that you just say it in words. Sometimes you make it mathematical, and then people test the hypothesis. Then there is a whole I'll say field of this hypothesis testing, or it's a huge topic in itself, the hypothesis testing. If you see this, so once you see the data, you will formulate your own hypothesis. You can say something about the data. You can say, I feel this data is, let's suppose if it is stock market, so you can say that I saw the data from past week, now I feel that the stock market will go up. You are making a hypothesis, then you have to test your hypothesis. Similarly, if you are running an e-commerce website, you are saying that I have seen the data, maybe my hypothesis is that this product is going to perform worst, we should not buy this. You take decisions based on that. Okay, so this is what this formulation of hypothesis means. Okay, so how is this performed? So how is this performed? You basically take statistical techniques, you see mean, median, mode, variance, standard deviation, all these things, and then you do correlation analysis. You plot different things. You plot a lot of plots, and then you do this statistical analysis. Okay, so in order to understand this data better. And some real world examples where it's used. The first thing, financial data analysis. If you take, let's suppose, stock market, if you see fraud detection, so you just have to ask the right questions. And similarly in the healthcare analysis, if we have patient demographics, patient history, and then we can see, okay, then there's a disease pattern. Maybe this demographic patients get this certain disease because of this. Okay, and what are the treatments and what is the success rate? And similarly in e-commerce and marketing. So we can examine the transactions and behavior of users and see their patterns and see their preferences. Similarly, in the climate, you can analyze temperature, precipitation, and CO2 data to identify the correlation between different variables. And there are a lot of things that you can do it. And you might have seen a lot of animations on this COVID data also. Okay, so that's what you have to do. Again, I'll write it. So this EDA, basically in this EDA. So again, to reiterate it, it's the best tool where you basically ask the data right questions, and the data basically spits out the facts, which usually are not seen if you directly see the data. That's why you have to ask the right questions to it. Okay, so in the let's suppose if I take time series data, there you will see this trend. Time series, like stock market data is time series data. You will see trend there. You will see some seasonality there. You will see that there are periodic change. You will see there are cycles. After certain things, after certain cycle, it's getting repeated. Okay, and things like that. And now we'll see this. What is the there are two things basically. This one is EDA, and there is something called as CDA. So in this CDA, this is called as confirmatory data analysis. Okay, I'll just write it somewhere, though I'll forget it. So there is something called as CDA. So EDA is when you explore this, and CDA is when you confirm this, because I told you there is a step where you formulate hypothesis in EDA. So in this CDA, what you basically do, you have direction now. So in this EDA, you are somewhat undirectional. You ask, it's an open-ended thing. You ask any question that is possible. You want to see something, you ask it. You go in different directions and to see, can I somehow find some pattern? Can I somehow do something related, so as to make it better, as to clean it, okay, as to feed the model better data. But there and then hypothesis made, there is some direction given to you. Then what you do is you perform this confirmatory data analysis. Okay, so it's a structured approach in that you after you have this hypothesis, you follow a predetermined plan. I have a plan. Okay, I want to confirm if this hypothesis is right. So you can do statistical hypothesis testing, confidence intervals, model validation, parameter estimation. A lot of things can be done over here. Okay, so but this step is also involved sometimes. But if you see EDA, so this EDA is undirectional. I'll say open-ended. So many of the people they keep on doing it. So sometimes it happens that you have to perform this EDA for weeks and weeks, so that you understand the data very well. And if you even were able to just correct one mistake, and sometimes the model performance increases drastically. Okay, that's why you should take it very seriously. Okay, now we'll go on to the pipeline again. So if you see pipeline, now you have got an understanding of what EDA means. So we'll see what this pipeline says. The first step in that is, many of the people, when you see tutorials online, so they'll start from probably this data processing or directly model selection. So but we'll see data collection. Okay, so we'll have to see it, because when you are in real world, the data doesn't already exist. Sometimes you have to figure out where to get the data from. Okay, some people who are doing project with me, they know what I'm speaking about. Okay, and sometimes you should not rely on the public data also. So there is some issue with the tab today. Okay, the first step, that is this data collection. Very important for most of you people, because sometimes you will have to figure out the problem, and I have a problem, and you have to start with this. And even the EDA, sometimes EDA can help you reformulate the problem. Okay, so you have a problem statement. Now I assume that one step that I am not saying, you have a problem statement at hand, you know what problem to solve. The first step actually is to find the problem, and this problem is getting I'm going to solve basically this problem. So once you have decided what problem to solve, and the second step that comes in, you have to do this data collection. Okay, so how to perform this data collection? The first thing in data collection is that you can have different sources. Okay, you can have primary sources of data, and then you can have secondary sources of data. Okay, so what are these primary sources usually? So let's suppose you have defined a problem, you have identified problem, and then also you have to now identify the sources of data. Okay, and that's also one more important thing. So now identification of sources is, you have primary sources and you have secondary sources. So what are primary sources? So primary sources are like, let's suppose you are going to solve a problem and there is no data available at all on the internet. So you have to perform surveys. You have to do your own surveys, and sometimes you have to let's suppose conduct experiments, because you have no data. You have to solve a problem. You have to do your own experiments to come with the data. Okay, or you have to do observations. If there is something and you have to observe that, and let's suppose sometimes you have to interview. It depends on the problem. So basically in this primary, you do not rely on any source. There is no source available, so you are taking the responsibility on yourself, and you are thinking, okay, I'll make this data. Okay, so that's the primary thing, because you are creating the data here. So you are creating the data in this case. So this is creation. Data is not available at all. So you are creating data. That's why it's called primary sources. Why? Because you are creating data and it becomes the primary source. And then secondary sources. If there is a data, let's suppose, involved. So once you have that data, so you can have government databases, you can have some research paper, there are some publicly available data sets. Okay, a lot of things can be there, and these will serve as secondary data sources. Okay, because now you have data available, you just need to gather it. So in data collection, what I told you, there are two ways to have data. Why am I telling you this? Because many people, they miss the importance of this. Whenever you start doing machine learning, they just directly deep dive on this part of, okay, you have data, you have the model. But when you go to the company, the first thing that sometimes you have to do is define a problem. Once you have the problem, you have to figure out data. Okay, just taking a digression again, I'll tell you a personal story. Once we started working on this meta, it took us at least 25 days to come up with the data. Okay, and we had to think what data to do. Okay, should we collaborate with some people so as to get the data? So this becomes very, very, very important. Once you have the field, once you have the problem statement, and then you have to collect the data. And some of you people that are doing some project with me on summarization, note summarization or something. So they are right now in this stage of making their own data, but they are taking it from secondary sources. Okay, there are online websites like MIT OpenCourseWare where they are scrapping it. Okay, and primary sources, because there was no question of, and maybe we also have some primary, so where we are taking these lectures and we have notes of these lectures also, we can also consider them in the data set. Okay, so now you saw that there are two sources, primary and the secondary. After you have this, so if you have enough secondary sources, what to do this? So what to do is, you can scrap the web. Okay, you can scrap the web, and there are a lot of things like Beautiful Soup is there, Selenium is there. There are a lot of tools by which you can scrap the web. And then the second thing is, in the scraping, I should say this, you should have the ethical considerations. Okay, you should see that you are ethically doing it. You should not take private data. Okay, it's very crucial to scrap responsibly, adhering to the website terms and conditions, and have this ethical aspect. Otherwise the model can get you in real trouble. So if you have data where it has something what's called as PII, personal identifiable information, so where we can identify somebody personally, and your model said something like this, it's very bad for the person who model creates. That's why these things come in. I know there are a lot of models where they were deployed, and after that people were sued for that because they gave some very sensitive information was leaked outside. Okay, and that's why once you fetch these web pages or scrap the web, be very because there are guidelines, there are something guidelines called as GPDR, HIP, if I remember the names correctly. So all of these are the organizations which keep you in check. So if something happens, so all hell will break loose. So keep these ethical considerations into once you scrap this. And but the second thing, there are APIs also. So secondary data, there are APIs. So what is the API? So some people have kept repository, like we have something called a UCI repository. Okay, we UCI report. Then we have something Kaggle is there. Okay, and a lot of other platforms are there where you can get the data available, which people have used for other projects, and then they are generous enough to make it public. Okay, and for the medical right now, which we are using, which is I think developed by MIT. So it's PhysioNet. Okay, and a lot of repositories are there. So they give you APIs. You can just use these APIs to come up with the data. Okay, and there are a lot of things. So once you have to search for the data, see if there are some APIs. See if you want to scrap the web if there is nothing available. Okay, and these are things that you can get your data from. Once you get the data, and after that you have to think how to sample. You have to appropriately sample it. Okay, then the stage comes sampling. Now you have a lot of data. So before formatting, we'll also see sampling. So sampling strategy is, okay, should we randomly sample, make a subset of this data because we don't feel this whole data should be used, or maybe let's suppose in this, if we have less data, should we augment this data? What should be done with this data? If it is less, we have to take a decision. If it is more, we have to take a decision. Okay, can we augment it? Can we also inject some synthetic data? If we have very less data, we can maybe generate some synthetic data by using generative AI, and will that work or something like that? And what is the quality of data? You ask these lot of questions, but again, reiterating, do care about these data privacy and consent. If you are taking, let's suppose, surveys and these forms, do take consent that I'll use the model for the training. Okay, sometimes people can sue you for this. Okay, now the most important thing, once you do EDA, okay, once you do EDA, many people, once they do EDA and they keep it themselves, but you have to document it really nicely. Okay, so once you do this EDA, so you have to document it. They're just general guidelines, because my job here is to prepare you for the real world. It's not just to give you theory. So once you are doing this EDA, please do document it. Whatever you're finding, document your findings. You will find a lot of things, so you have to document these findings. Okay, and you have to keep track of this progression. Okay, we did this because our brains, as I usually say, they are not built to memorize everything. Okay, they usually see the pattern. So whenever you find something, do write it somewhere. Okay, and see the initial observations, and then make these plots, make hypotheses, ask questions, and make the decisions. All of these things should be documented. Okay, whatever I said, these things should be documented, so that when other people take it, if they see, if you, let's suppose, see the model is not performing good, okay, let's go back to the initial step, let's see if data is not good, let me ask again some more questions. If you have documented it rightly, then only can you go back to that step. If you have not, and you believe that I have done everything right, then there is no scope of improvement in the model. So it is better to document this. Any questions on this? Now that we have seen what EDA is and what CDA are, what are different things, and why do we do EDA, and why is it important? Now we'll select in this basically this series of sessions. We'll take many data sets to perform this EDA, and from each data set we'll somehow learn one aspect. We'll somehow learn from one thing what to do. And now the first data set that we'll start with is called as IRIS data set. IRIS. I have been speaking about this a lot in previous sessions. If you know, this is a data set. So this data set is very famous data set in machine learning and statistics. So it was a British statistician and biologist. His name was Fisher. So he collected the data set. Okay, I think in 1936. I have written the date over here. Okay, it's very easy data set and not I'll say that complicated, but it is good enough to explain the basic EDA. And we won't just use the data set, probably we'll use some advanced data set also, because this is good for a starting point. But once we go to the advanced techniques of EDA, then we'll need more advanced data sets. The first thing is we'll use this IRIS data set. So now I'll tell you what this data set is. So it has basically flower data. Okay, because the guy was a biologist, in particular botanist. So it has flower data. So there are three types of flowers. Okay, Setosa, Virginica, and versicolor. These are the flower types that there are. Okay, and there are features also. So okay, these are classes, flowers or classes, or I'll call them labels. Okay, and there are the features. What are the features? So features are petal length, okay, petal width, sepal length, and sepal width. These are the 4 features in the data set. So I'll call them features, and I can also call them independent variables. Independent variables. In terms of mathematics, here I can call this dependent variable. Dependent variable. Okay, so this is the data set. Okay, if you see this, we'll see it in analysis how many data points there are. So first, I just gave you a brief introduction of the data set. Okay, so what is a petal and what is sepal? I'll assume this if I can show you a flower. So flowers are something like this. So there are these 2 types of, so I'll call them leaves. So there is one bigger leaf which is probably called sepal, and there is a petal, something like this. Okay, so if you see, this is the width and this is the length. Okay, similarly this is the length and this is the width. Okay, now the task was based on this petal length, petal width, and sepal length, sepal width. The task was to classify these flowers. If I give you some data, so people should be able to, okay, oh my god, it goes back here. So people based on these features, we should be able to come with the class or the label of that flower. Okay, which type of flower is this? That was the problem at hand. Now if you see, the first thing is we'll have to get this data somewhere. So it is in UCI repository. Okay, so this is the data set that we have in hand. So now the first thing is we have to collect this data, but as I said, we won't do the experimentation as Fisher did. Sorry. So what basically we'll do, we'll use secondary sources. The secondary sources, this can be downloaded from UCI repository, this data set. Very easy. So I'll just switch to the code window. Give me a second. So now this is, I got the VS Code up. Now if you see this, I have imported this matplotlib numpy pandas. Why we're doing it right now? Because we have almost seen all the libraries that we'll be using here. So how to take the data set? So you can download it from this URL. Okay, I'll just paste a URL if you want to download it. So this is the URL for the data set. Okay, archive ICS UCI edu ml machine learning database and iris.data. So this is the URL, but I have kept it somewhere. I have downloaded it. So I'll just write path. I'll just give the path name. I think iris.data. So I'll check if it is there. I have named it somehow. It is here. If you see iris dataset.cv, okay, I'll just take this. Okay, I'll paste it over here. This is the path of the data. Okay, so I just want to delete this. So this is my data set. I have already downloaded this. You can just even read it from URL. So now what I will do is I'll just read this iris.df. I'll read it. I'll read it as CSV. If you see this, so column names, I'll not put it. I'll just give the path so that I read it, because this data set is actually in, it doesn't have column names. I can put column names. So if I just say the iris df.head, you can see it shows 5.1, 3.5 iris setosa, and I just want to put columns, because column names, these are the column names. I told you these are the column names. Call sepal length, sepal width, petal length, petal width, and class. Okay, so now I'll put this column names as column names. So that's what I do. Column. This is actually names, not just column names. Name is equal to column names. Now if I read it, you can see that I got sepal length, sepal width, petal width, and the class. Okay, this is my data set. Okay, if I just want to see, initially I just printed this df.head, wanted to say data set. I just check these columns that I myself introduced, and this is the indexing. You know, pandas enough now. The first thing is I want to see how many data points are there and what columns are there. So in order to display the shape, if I want to display the shape, you know, the simple is the iris df. Okay, this is iris df dot shape. Okay, this will tell me the shape. Now if you see the shape is 150, 5. So what does this mean? This means that it has 150 data points and 5 features, not 5 features, rather 4 of the features, and 1 is the class. Basically 5 variables are there. Okay, among them, 1 is the label or the class. So if you see this is our data matrix, some sort of things like that. So this is our data matrix. Okay, data matrix. Now we are also using the algebra terms. So now if you see these things, so all these features, okay, so they are my features or independent variables, because they can take any value. This is my class or label. Okay, class, label, or dependent variable. Okay, and this is the indexing. This 150, 5, this tells me that total data points are 50. 150, sorry, total data points are 150, total data points. Because if you see, each of this row is a data point. Okay, this is a data point. Okay, so that's what it's saying here, 150, 5, and we have these 4 features and 1 class. That's why we have number of columns is 5. Okay, this is how we saw it. The first finding is this. That's why you can store it somewhere when you're doing EDA. The first thing is you want to see how many data points are there. Okay, now if I let's suppose I know the columns here. So if I want to see the columns, you know how to print the columns. Dot columns is the function. So I'll say df iris df dot columns. So if I just print it, so it will tell me sepals with this, and these are the columns that I have in the data set. Okay, and then I can also see tail. Okay, you know iris dot iris df dot head we have, and then we have tail if you want to print the last. If I just want to inquire about data set, so what is there? So you can see these are the things. Now I want to see what types of columns are there. Okay, so let's suppose if you see all of these are float values, but generally all the things will not be floats. So for that, you know the function, so you can check iris dot d types. We have seen this in pandas. So iris df dot d says that sepal length is float, sepal width is float, petal width is float, and class is an object. Object basically it here is a string, so it is a pandas object over here. Okay, now I can take some stats. Okay, I can take some summaries from this. Okay, I'll say iris df dot describe. If I just make it iris df dot describe. Okay, now you know I'll explain all of these terms over here. Okay, so now we have the sepal length. You can see the count over here. So count over here is 150. That means all the points have this sepal length. So that's why 150 is there. Same for the sepal. So we have here different terms. Let me zoom it a bit. Okay, now if you see, this is the table that we have. So in here, the first thing is count. Count basically tells you the number of entries there are. So if you see, we have 150 data points. That's why all of these entries are 150. Now this is mean value because it's a float number. So it is taking mean value. It is taking sum of all the observations divided by the number of observations. It's taking the mean value of sepal length is 5.84. Okay, and sepal width has mean value of 3.0504, something like this. And similarly for this, and then it is standard deviation. Okay, so you know standard deviation, what that is. Okay, and we'll see these concepts in detail, what deviation is. This is count, this is mean, this is standard, and this is the minimum value. So what is the minimum value? 4.30. Okay, then we can see these quartiles also. This is 25th, and this is Q1, Q2, Q3. Okay, we have seen quartiles, quartile 1, quartile 2, quartile 3 when we were explaining matplotlib, and this is the max value. Okay, so once you just have this df.describe, okay, and it shows you all these statistics. Okay, these are sort of summaries, these are statistic values. Okay, we have mean, we have count, we have standard deviation, minimum value, maximum value, and the quartiles Q1, Q2, and Q3 there are. Okay, there are all of these things. If you just want to have a look, and you can see this. So this thing is a little bit higher than other means. So this is 5. So that means sepal is the bigger leaf. Okay, I was telling you that there are these, if I call them leaves. Sorry if some botanist might be watching it later, he might curse me on using these terms. So if you see a flower, so there are these big leaves and the small leaves. So one is called as sepal and another is called as petal. Then you can clearly see this is greater, 5 is because length is way bigger. Again you can see this, the width is also bigger than this. So you can see 3.7 and 1.9 is 3.7 is less than 5.8 and 1.9 is less than 3.5. That tells you that petal is a smaller leaf. Okay, and then you can see standard deviation. So deviation is a little higher here, so that variability of the data is way more. Okay, it is 0.8 variable. That means sepal length varies a lot. Okay, that's a conclusion you can take it from here. Okay, so if you see petal length varies the most. Okay, petal length varies the most. You can see this. Minimum value is 4.3. Okay, and here if you see minimum value is 4.3 and 5.8 is the mean value. That means minimum value, this data is not that much spread across because minimum value is 4.3 and the maximum value is around 6 and around 8 is the this is max value and this is mean value. You can consider it like this. And if you see minimum value over here is 3 and there is a difference of 1. Okay, similarly you can see the variability is quite high. Okay, that's why you see the standard deviation is quite high in here. Why? Because if you see this minimum value, it's 1, mean is 3.7, max value is almost 7. That's why you see the variability of data is very high. That's why standard deviation is very high. It's 1.7 because you have mean is 3.7, minimum value is 1 and max value is 6.9. Okay, that's why you can see the data has high variability. And how to measure variability? By deviation. Okay, how is it? That's why you get a high number of deviation. Okay, and these things are like having good deviation. So if you see this number, it has very less deviation because why? 3 is the average, 2 and around 4.5. These are the max and min values. That means variance of data or standard deviation is very less. By just seeing this data, I can tell a lot about this data. I can tell you a lot about these things. I just told you how to read these things. Okay, now let's suppose if I want to see how many data points are there in each class. Okay, in each class I want to see data types. So how to do that? So I'll just select that column because I have column, I have the value counts. Okay, just going to the code window and showing you there. Okay, now we'll see how many classes are there. So how to do that? I'll say class count. Okay, and then oops, this is also a way that it says, and then we have class dot value counts. So I'll say class counts. Okay, and then you can see this class is this. So if you can see over here, the class is iris setosa. It has 50, it has 50, and it has 50. Okay, this data set is called as balanced data set. There are different types of balanced data sets based on number of points. So if you see, there are 3 types of classes in it. This is a classification problem, because the problem we are solving, we have to classify flowers. So this data set is balanced. Okay, what is the meaning of balanced data type? If the points in all the classes are more or less similar, so it is here 50, 50, 50. So if it was, let's suppose 41, let's suppose 38, and some 45, this is also balanced. Okay, because they're approximately almost similar. But there is something called as imbalanced data set. Okay, imbalanced. So this is balanced, we have imbalanced, where we have a huge imbalance. Let's suppose we have A, B, and C classes. This has some 1000 points. Okay, this has some 20 points, and this has some 48 points, something like this. So if you can see, this is heavily imbalanced data set, and usually sometimes there are real world data sets which are heavily imbalanced. As an example, if you are detecting cancer, okay, in the patient, so you see cancerous patients are very less. That's why you see, if I call cancerous patients as A and non-cancerous as B, you will see a ratio something like this: 100 patients out of, let's suppose, 1 lakh, something like this. This is heavily imbalanced data set. Okay, most of the models, I'll say most, perform very badly on this imbalanced data set. So this is imbalanced data set. They perform very poorly, and we have to somehow come up with techniques so as to solve this imbalance in data set. Okay, and some of the times you will have balanced data set, but most of the times you will have this imbalanced data set. I just wanted to point it out over here. But if you see this, why I check the number of points, I wanted to see if the data set is balanced or imbalanced. If it is balanced, good, I can use some certain techniques. So if it was imbalanced, then I'll have to think, okay, how severe is the imbalance, then how can I deal with the imbalance. That's why here I just wanted to show you, and next data set we'll take should have heavy imbalance, and we'll see how to do imbalance. Okay, if I just want to describe for let's say only one, we described it for, if you see the previous describe function, it described all of these features. Let's suppose now features, hundreds of features are there, but you just want to describe one feature. So you know how to do that. Just select that column and describe. So iris, sepal length, and describe. It will show the whole of the thing, the column of that thing. Okay, because sometimes your data will be huge, and this describe function, it won't fit on the screen. So it is better to do it one by one, by feature wise. So this is what you can see. It will show exactly same thing that I have above, but it will just show it for the single column. I think we have a question. Just give me a second. Yes. Okay, now we saw a lot of things that can be done, and most of these things were covered in Pandas, so I'm just glossing through them. And now you have a brief idea about what types of data is there, how many points do we have, how many columns we have, what is the class that is predicted, and maybe we can have a discussion with the botanist. Okay, what is this feature talking about, and why is this feature important? Okay, all these things are there, and we can find the correlations. Right now I won't do the correlations, maybe I'll do correlations later, because I have not introduced the concept of correlations. Okay, and before going to doing some other EDA, because now we have at least data, so now I want to clean the data. Okay, that is my job. Now I want to clean this data, and I want to prepare the data for the next stages. So now the next topic comes in: data preparation and pre-processing. Okay. By no means am I covering all the details. Okay, I'm just covering enough details so that it will get you started. The more you do it, the more you will learn along the way. As I said, sometimes it becomes more than art than a science. The more you do it, the better ideas you get. Okay, so this is the data preparation and pre-processing stage. So we are learning both the things together, because we are performing EDA, because we want to prepare data. Okay, from this EDA, that's the step, and that's why I wanted to intertwine both of these things. Now the first thing is that I have to do data cleaning. Okay, I'll tell you the steps, and then we'll see it on the real data also. I'll tell you these things. The first step that we have to do is data cleaning. Okay, so what is the data cleaning? Data cleaning is basically to address errors. There might be some errors in the data, so there might be inconsistencies. Okay, and some missing values, so let's suppose some irrelevant information, and much more can be there, which is basically noise. Cleaning, basically all of this I can consider this as noise. So I have to somehow remove this noise. Okay, and I have to clean the data. Okay, now how to clean this? What can be done? The first thing is that you have to handle the missing values. I'll just list them first and then we'll go in depth in each of these things. So I'll have to handle missing values. Handle missing values. Many of data set, almost the data set that is sort of cherry picked by people may not have this missing values, but the data that is in the real world, almost 90% of them will have some missing values here and there. Okay, that's why this is a very important topic. So now you have to initially identify this. You have to identify the missing values. Okay, then you have a lot of techniques how to handle these missing values. So what are these missing values? So if you have a certain column like this and sum of the entry is not a number, if it is a number, or sum of entry is empty, total empty. Okay, and we have some entry over here which doesn't contain anything, so there are missing values for that feature. Okay, and we have to handle those things. So this is one thing that we have to deal. And then there may be duplicates. Okay, because we are cleaning the data. Now there may be duplicates. Okay, the first thing I said is handle missing values. I'll keep on writing it here, handle missing values. And then we have duplicates. So what are the duplicates? So you can have values where we have duplicate values. Sometimes you have we have multiple copies of the same data point. Okay, and sometimes you collected data from different let's suppose sources, but the thing is you got duplications there and you have to somehow deal with these duplications. I think we have a question. Yes, go ahead. So now if we have duplicates, so we have to ensure the data set is free from this repeated rows, or maybe let's suppose if you have repeated columns also sometimes. So it is better to just avoid these redundant data points. Okay, remove these redundant points. Remove redundant points, because you want to have a variety of data. You don't want to have duplicate data always. And then here I say you have to handle missing values. Handle missing values. I actually wrote that. Okay. Then you have to sometimes correct errors and inconsistencies. Let's suppose there are typing mistakes, there are inconsistency, formatting is wrong there. Okay, fixing typos if there are typing mistakes done. Okay, and if there is inconsistent formatting. Okay, and these things sometimes apply on if your data is based on strings and these things. And then let's suppose there are irregular units used. Let's suppose if you give the data collection to multiple people, some may measure things in meters, somebody in centimeters. Temperature is measured somewhere in Celsius and Kelvin. So you have to standardize it somehow. Okay, and then you have to standardize date formats also. Some date formats may be different. And then you have to correct use. Let's suppose sometimes somebody can write country name as USA, somebody is United States. Okay, they will be treated as two different things, but you have to sort of standardize these things. Okay, and that's why I'm saying correcting these errors and fixing these typos, inconsistent formatting, irregular units. All of these things have to be done. So this is the data cleaning step. Okay, and we'll see all of these things one by one. All of these things will be seen one by one. Okay, then comes the next step. We are in the part of data pre-processing and data preparation. Now data cleaning is done. Once the cleaning is done, now we'll have to transform the data. Okay, that's called as data transformation. So what is the data transformation? So now you have to enhance this data so as you can use it for the models, because you know that all the things the computer understand is numbers. So you have to somehow convert into numbers which machines will understand, and they will give the better results. The first thing is you have to encode. Okay, you have to encode the data. So let's suppose if and there are a lot of types of encoding. Okay, if I take, let's suppose, an image should be encoded into pixels. If we have image, I'll just write them. So image can be encoded into pixels. If we have audio can be encoded into spectrograms. Okay, and spectrogram, they are just numbers. Okay, and let's suppose if we have text. So text, there are a lot of techniques. There is something called as TF-IDF. Okay, and there is word to vec. Okay, bag of words. A lot of things are there. Okay, I think this is the best. This word to vec. Okay, and which people usually use. And if you have other things, and that you accordingly convert them into numbers. Okay, if you see these sort of things, image and audio, probably this is a video, so this is computer vision task. So if you see this is an NLP, natural language processing task. Okay, and then there can be a lot more data depending on the data. Okay, sometimes you measure electric signals and a lot of things can be done. Okay, you have to encode this information. Okay, whatever encoding you have, and then you have to see if this is a number, and there are a lot of types of encoding. As I said, just mentioned pixels, and encoding can be label encoding. You assign a unique number. Let's suppose we have iris dataset in which we have setosa, and we have versicolor, and we have virginica. Okay, now how to encode them? I have to make them numbers. So one encoding is, if it is a flower, so I'll give this 0, 1 and 2 number. Okay, so this is called as label encoding. Okay, or maybe let's suppose if I can make it one hot encoding. So if it is setosa flower, so I'll make a number like this. I'll say setosa for 1 and rest for 0 0. If it is a versicolor flower, I'll say 0 1 0. Virginica 0 0 1. So this is called as one hot encoding, where you just put 1 at the place which it belongs to. For rest of the column you put the 0. It's called a one hot encoding. Then we have ordinal encoding, where you have meaningful order. Let's suppose low, medium, high, okay, something like this, or you have some other like meaning of that. So there are a lot of types of encoding that we will see. And after this, after we are done with encoding, this is encoding. So encoding has to be done for the columns, for the features as well as for the targets, if it is a supervised learning setting. Then what we do is we do what's called as feature scaling and normalization. Feature scaling and normalization. All of these steps are really important. Okay, so what is the meaning of that? So I'll tell you this. So why do we do feature scaling? Let's suppose you have two things that are there. Let's suppose two things. So let's suppose somebody is measuring weight and somebody is measuring, let's suppose, blood pressure. So if you usually see weight is in the range of let's say let's say 30. I'll take the least value as 30 and the max value, let's say 150. Okay, but if you see blood pressure values, so blood pressure values are starting from 90 to, let's suppose, I'll take 80 to say 300, something like this. Okay, so if you see, this range is quite different. Okay, when you are making the model, so model will take some combination of these, some non-linear combination, and make the prediction. But if you see, this blood pressure will somehow have more impact. Why? Because it's a bigger number. So in order to get it into the range, so what we'll do, we basically normalize it. Sometimes we may normalize it between 0 to 1. We do not give these actual numbers, so we normalize it. Okay, and that's called as min max scaling. If you do it 0 to 1, sometimes we standardize numbers. We center the data. Okay, there are something called as min max scaling. We'll all see all of these. So min max scaling, there is something called as, or normalization, there is something called as standardization. Okay, all of these are mathematical formulations where you choose, and then we can sometimes use log transforms. Okay, so as to get it into a scale which is standard, so that your one feature does not impact the model much, because maybe it has a higher value because of that. Okay, then you do what's called a data discretization. Okay, once you have encoding, you did the feature scaling, then you do data discretization. Okay, data discretization. And what is this? So in this, basically you convert a continuous data value into discrete bins. Let's suppose now you have continuous value, range of values. Now you know that continuous value, it can take infinite values. So can we do something? So if it is needed sometimes, can we do one thing? Can we just discretize? Let's suppose age is a continuous number. Okay, it can start from 0 to, let's say, 150. Now it is good if we have to encode it, we can just keep the number as it is. But can we just do it, make it a categorical variable? Can you somehow discretely categorize it? How can we do it? We can say child. Okay, we can say teen, we can say adult, something like this. Okay, we just made 3 categories. So we had a continuous variable and we discretize it. Okay, and there are a lot more techniques that you can do with the data. You can encode the data, and you can just take this and you can, and now you have to imagine. The more you imagine, the much things you can do. Okay, this I'll leave open-ended. Okay, whatever you can do some other tricks and techniques on this for the particular data set. Okay, you should see the problem as this. You should see a problem. Now you are not just following the standard procedure. You know these techniques, and these things do happen there, these are in the real world. But what you should do actually is, you should ask right questions. Okay, can I encode the data into this? Can I come up with new encoding techniques? So if you can do that, that will be way better. So what I was speaking about is, you should not care about I have these techniques. You should rather ask questions. Can I somehow come up with new techniques? Okay, to encode data, to normalize these things. Okay, to do feature scaling. Can I somehow do something which suits the data set, which suits this particular problem? Okay, so what you do is, initially you encode the data, and then what you do is you transform the data. And after transformation, sometimes you feel there is a lot of features. Can I reduce the features? Can I somehow make my model a little simpler? So you do data reduction. Okay, in this you have techniques like PCA. Okay, you have techniques like TSNE. Okay, all these techniques, they'll help you to reduce the number of features. Okay, so that you can remove irrelevant features. You can use some combination of different features to just make them one feature. Okay, so this is what data reduction is. So because the more data you have, the more time your model will take. Okay, that's what these things are for. So you do data reduction. So the first reduction is dimensionality reduction. So this is what I said, dimensionality reduction. Okay, you have a lot of dimension, basically a lot of features. You just want to shrink the data, have less number of features, so that your model performs good. Then you have sampling. Okay, you can sample very good data. Okay, yeah, you can do stratified sampling. There is something called as active learning, and you basically want good samples. Okay, you want to sample good data. Okay, good. By sampling, if you are, let's suppose, a million points, but all these points, there are only some good, let's suppose, some good 200k points. So it is better to keep those unique points within data, because you want to make machine learning model learn more, not just have the repeated values, and if they're very, very less. So it is better to keep very good samples. Okay, you have to come up with sampling things. Okay, so we're in the data pre-processing and preparation stage. We'll see all of these stages one by one, but I'm just right now enumerating these. After you have the reduction, now what you do is you handle the outliers also. Okay, there are outliers also. You have to handle outliers. As I said, what an outlier is which does not follow the norm. It may be because of typing errors, and you can directly eyeball sometimes it. Okay, and you can have identification. For the first step is you will identify this. Okay, there are techniques of identification. Okay, there are statistical methods like z-scores, IQRs, then visualization like box plots, scatter plots, and you can visualize them. Then what is the treatment? So this is identification, how to treat them. Okay, we'll also see these methods in code. So you can remove these extreme values. Okay, you can cap these, you can limit. Okay, from this I won't accept it. You can transform these, you can apply techniques like square root transformation, log transformation, and stuff like that to handle these outliers. Okay, and the next step is called as data integration. Now if you have less data, which I just spoke about in our discussion, okay, now you have to take a decision. Can I use different sources? Can I combine different sources of information so as to make a good data set? Okay, can I do one thing? Can I use synthetic data? Can I augment data? Okay, here we'll read about augmentation, different methods of augmentation. Can I augment this data? Can I use synthetic data with by which I can augment? Can I, let's suppose, combine different data sources? Okay, so as to prepare data, because we are in the stage of preparation and pre-processing. We are preparing data and pre-processing so as to feed to the next stage. Okay, and then you can remove the conflicts, let's suppose, if they are inconsistent in different sources, so as to do the better things. Okay, and after this you do feature engineering. After this you do feature engineering. So what is feature engineering? Now you have collected a lot of features, let's suppose. So among them only some are relevant. You are feeling only this is relevant, and if you talk domain experts and if you do a lot of analysis, they'll say, okay, you can remove this feature, this is not good, this is not good. So for that you may sometimes create new features, you remove the redundant features, you see how can I combine multiple features into one. So you do this feature engineering. Okay, then you have to also handle imbalance. Okay, you have to handle imbalance in the data set. If it is imbalanced, if there is imbalance, then you have to handle the imbalance. So there are imbalance techniques like oversampling, undersampling. There is something called as CSL. This is called as cost sensitive learning, and all these things have to be done. And after you are with this, then you separate the one. Once you have the data, in the format that you want it to be, in the right format, in the right manner, and rightly clean. So after that, what you can do is you have to partition the data. Okay, you have to partition data. Okay, what's the meaning of partition? You have to have training split, you have to have cross validation things. Okay, you have to have test, you have train, and you have to have validation, so as to give the right data to the training model, and then you have to have parameter tune, you will do validation set, and you will do train, and all of these are separate topics. So in here we'll learn about cross validation. Okay, how can we use this? And we'll say there is something called as leave one out cross validation. There is something called as k-fold cross validation. Okay, so in this testing data, okay, which data should be used for test? Can I randomly shuffle them first and then use it for test and train? How to split it? Okay, and some data sets are, let's suppose, time series are there, then you have to handle time series data also. Okay, and some final considerations have to be done. It is on the space data. All the things that are discussed in this data preparation and pre-process step, they are more generic, but once you have the data, you have to think in terms of the data. But these are some generic of the things that we usually do once we have data. Okay, if you have any questions on this, I am willing to take them. Otherwise, I'll stop the recording over here.